Okay, so today I'm going to be comparing our standard algorithm, 134 times 256, by our Lattice algorithm. So when we're doing the Lattice algorithm, these boxes here are representing longs over units. So if we're in the tens place and we get like 11, we have one full 10 with one left over in the units. So the most important thing about the Lattice algorithm, and something that is similar to the standard algorithm, is that the Lattice algorithm is set up by place value. So the hundreds is right here, hundreds right here, tens right here, tens right here, ones right here, and ones right here. The second thing that is similar to the standard algorithm is that we account for every single digit. So the 134 needs to be completely multiplied by 256. And as you see us go on throughout this, you will see that the 134 is completely multiplied by the 256, like it is in our standard algorithm. So let's just begin. We're going to begin with multiplying the hundreds by the hundreds. So 100 times 200. You're going to get 0, 2. Then 30 times 200. So that's going to be 6, which is actually 30 times 200 if we're really doing this. So I'm pretty sure it's 6,000 and 2,000. Let's just be sure. 0, 0, 0, 0, 0, 0, 2, 4, 6. Yeah. So 6,000. Then this is the ones times the hundreds. So 200 times 4, which is going to give us 800. 0 and 8. We had no full groups of 10, and which is why all of our longs are still at 0. Here you can see though that we accounted for the 200s and the 256 were completely accounted for. We multiplied the 200 by the hundreds place, we multiplied the 200 by the tens place, and we multiplied the 200 by the ones place. So now we're going to completely account for the tens place by multiplying the tens place by the hundreds place, the tens place, and the ones place. So 1 times 5, and this is actually 100 times 50 because this is the hundreds and the tens place. Then we're going to do 30 times 50, 1500. So we're going to have 1, 5, and then 50 times 4, which is going to be 50 times 4, I believe 200. Yes, I did. Yes, 200. So we have 2 and 0. Then we're going to completely account for the ones place. So the ones is going to be multiplied by the hundreds, by the tens, and by the ones. So 100 times 6, 6, 30 times 6, 180. Yes, I still use my fingers. I know it's not very good. So we have the one up here because this is the full 100, and we have 80, so 8 left over. Then, and this will be explained, this accounts for 80. Like this is 180, and even though it's 80, we can still represent it as 8 because, as I will show later on, this is actually the tens place. So that 8 is showing us 80. Lastly, we're going to do 4 times 6, so 4, 8, 24. So we have 20 right here. Once again, this 2 is in the tens place. You'll see that when we do the diagonal, but so this 2 is accounting for 20, and we have 4 left over in our ones. So this is all the math done out. Now we have to account for place value even more. So right here is going to be our ones. We know this because 1 times 1. So that 4 represents our ones. Next, we'll move over to the tens place. 10 times 1 is 10. Right here, we have ones place times ones place. The reason, though, that this is in the tens place is because, as we saw, this 1 equaled 24. So we had to carry over 20, which is why this 1 and 1 is actually in the tens place, because this actually is a 20. And then this one is 10 times 1, which is once again 10. So this 8 plus 2 plus 0, that's going to give us 10. So we will add this over to the hundreds place. And all of these will be accounted for. So 6 plus 1 plus 1, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. So we're going to have to carry the 2 over. That was for the hundreds place. And as I showed earlier, you can see this because hundreds times 1, hundreds, 10 times 10, hundreds, and so on. This all equals the hundreds place. Now we're moving over to the thousands place. We added the 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14. We're just going to set this 4 down and add over 1 to the 10,000s to give us 3. And in the 100,000s, we have 0. So our final answer comes out to 34,304. The most important thing about this algorithm is that we accounted for each of the place values. The place values all matched up correctly, and you were able to see that that happened through 1 times 1, 10 times 10, 10 times 100, so forth, that all the place values matched up. Lastly, that we added all the place values, which we did here, and also that we accounted for the 256 completely multiplied by 134, which we did because the hundreds completely went into the 200s. The tens did, the ones did, the tens completely went into the hundreds, tens, and ones, and the ones completely went into the hundreds, tens, and ones, like with our standard algorithm. We will do our standard algorithm very quickly. I actually have it already done so that we don't have to take too long. This is 4, carry with 2, 0, 8, 2, 0, 0, 7, 6, 0, 0. Sorry, I did the work here, so just kind of showing the work so it's not taking too long. As you can see, 4, 0, 16, 17, 8, 3, 2, 6, 12. Oh, okay, so this 2 was just accounting for that 2, 6, 12, 13, 14. Yeah, 14. 1, 2, 3. And as we see, we arrive at the same answer. So, like our standard algorithm, the Lattice algorithm explains carrying over. As we carried over the 1, we carried over the 2 to different place values, and it also accounted for each place value being multiplied as the standard algorithm does, because the standard algorithm is 6 times 4 times 3 times 1, 5 times 4 times 3 times 1, so on, just as the Lattice algorithm did. Thank you.